Alright, this is a video to focus on solving washer problems that are a little bit more difficult, harder to find the big radius and the little radius, and it's good review for the Chapter 6 test, of course. So here's our first problem. You might have seen this one before. Find the volume of the solid formed by revolving the area bounded by y equals x cubed, y equals 3, and x equals 0 about the line x equals -2. So we got all the facts and we're going to run through the steps of solving this thing. First thing's always to graph it. So let's set up a graph and get this thing going. So here's my xy axis. And the first graph is the curve y equals x cubed. So that's the typical curve that we all know. It's the one that goes like this. And I'm going to label it so I don't forget what it is, y equals x cubed. And then it's bounded by y equals 3 and x equals 0. So y equals 3 means if I go up to 1, 2, 3 here, we've got a line right there. Y equals 3. And x equals -2 is where we're spinning. X equals 0 is the axis here. This is right here. It's hard to see it, but this is x equals 0. So the area that we're spinning is bounded in between here. It's going to be in yellow. That's what we're going to be spinning. And we're going to spin it around the line x equals -2. So x means go to the x-axis to -2 here, and that'll be our spin line. That's the thing that I'm going to draw my little revolving arrow around. That's what I'm going to spin around. So we got our setup, we're all ready to go. I can see it's a washer problem. I can see that if I'm spinning around that axis, it's like spinning around the y-axis almost, just moved over. So you can see that there's going to be this big gap in the center. So it's a washer problem, and I'm going to draw a picture of my washer. It's always a good thing to do. It's going to go that direction. Here's the washer. It's going to have a big radius for the entire washer. We'll call it big R, and it's going to have a little radius as far as the little hole goes. Because we're spinning around what looks like the y-axis, the radiuses, or radii I guess, are going to be in terms of y. It's going to be a dy integral. So first thing I need to do is I need to take this y equals x cubed function and I need to cube root both sides so that I can rewrite this. This is really x equals y to the 1/3 power. I want it in terms of y. So change it to x equals y to the 1/3 power. Then let's look really carefully at how we can write an equation. So big R is the farthest from where you spin. So if this is where I'm spinning, right here, big R goes from here all the way out to the end point. So what I would say big R is, I would say it's determined by the curve, y to the 1/3. But y to the 1/3, it only tells you the distance from the axis to the curve. This dotted line is y to the 1/3. So it's like we need to add an extra length on here. It goes from here to here, yeah, but you need to add 2 more on. So you need a +2. Little r is the gap. Little r goes from here to here. This is little r, if you can see that. It's the space, and it's a nice space of 2 units, so I'm just going to say 2 units. I'm not using the number negative. I know it's -2 on the graph, but I'm not using the number -2 because you're not going to have a radius of -2. Doesn't make any sense. Radius, it's going to be measured in a positive number, so +2. And I'm going to set this problem up. I probably need to draw my 3D solid also. So my solid, I'm going to be moving this region, is going to look something like, let's see, here's the beginnings of it. It's going to flip around this line, so it's going to have some symmetry over on the other side. So I'm thinking something like this is going to be my solid. Okay, that's what we're finding the volume of. Let's set it up with a formula. So I'll scoot this up. Alright, so volume equals pi integral, and it's big R of y squared minus little r of y squared dy. It's all in terms of y's. And the bounds are going to be in terms of y's also. So look at the y-axis. right here, the bounds are going to go from 0 to 3 if you're looking at this. So 0 to 3 on my integral. I can plug in my r's and I can solve. So volume equals pi, integral 0 to 3, and big R is y to the 1/3 plus 2. And I'm going to square it. Minus little r is going to be 2 squared. And then the whole thing will be times dy. And I can put a big bracket around it or something. And then that's the integral we got to solve. And we can FOIL all this out and we can solve the integral. By now we're getting pretty good at that. It's the setting it up that we're really trying to practice. So now you can solve this thing by hand later and get an answer. I'm less concerned with the answer right now. I'm more concerned with the setup. So let's practice setting up another difficult washer. Okay, here's our problem. Find the volume of a solid of revolution formed by y equals radical x minus 3, y equals 0, and x equals 7 about the line y equals 10. You might pause the video and try and draw it first by yourself, see if you're good at that. I'm going to jump right into drawing. I'm going to set this up as a square root function, and it's square root x minus 3. So it's shifted 1, 2, 3 to the right. So it's looking something like this. Y equals radical x minus 3. And it's bounded by y equals 0, which is the axis here. So it's bounded by the axis. That's y equals 0. It's bounded by x equals 7. So here was 3, 4, 5, 6, 7, we'll say. It's bounded by this line right here. X equals 7. So I can see my shaded region. It's right here. And it's revolving, if we read this problem carefully, it's revolving around y equals 10. So y equals 10 is going to be like somewhere way up here. I'm going to make this up. Let's say it's right here. Y equals 10. Which means we're going to spin around this thing. So I'll draw my little spinny arrow. And it's another washer problem. If I'm going to spin the yellow region has a rectangle that looks like this. So we can see that there's a big gap in the center here. And I want to set this up and solve it right. So let's be really careful. If this is 7, let's find this point of intersection. If I plug 7 into here, it'd be the square root of 7 minus 3, which is the square root of 4, which is equal to 2. So this is at y equals 2. So over here, this is only 2. So maybe I should have drew 10 even higher up, but just to get a good point on the graph. So things we need to do. Let's draw the washer. First things first, the washer is going this direction. It's got a hole in the center. So here's my washer. It's got a big radius and a little radius, and this time we're spinning around a line that's a whole lot like the x-axis. So we're going to find the big R in terms of x's and the little r in terms of x's, and we're going to have a dx integral. Big R is the farthest from where you spin, so let's work on this. Farthest from where you spin. If this is where I'm spinning, farthest means from here all the way down to the bottom, which I already know, like, okay, if this is big R, that's a length of 10. I can measure it with a solid number, so big R is 10 units. Little r is the gap. Little r goes from, do it in a different color, little r goes from here only to here. That's little r. So that distance is right where it hits the curve. Well, the curve, radical x minus 3, this thing, that equation tells me the length from the curve down to the axis. So I'm going to say little r is like if I took all 10 here and subtracted the curve away. So if I took all of the length of 10 from all the way up here and then subtracted radical x minus 3, that would be my little r. So I'm going to set up my integral. Volume equals pi, integral, big R squared minus little r squared. So big R is 10 squared minus little r is 10 minus radical x minus 3 squared. And it's a dx integral. And the bounds, since we're talking x's, are based on the x-axis. So we're looking at bounds from, I'd say, 3 to 7. So 3, 2, 7. And we're ready to solve. We're going to FOIL all this out and plug in bounds and do our integrals. And that part won't be hard. But getting the setup is always the hardest part. We also should probably try and draw the solid on this one. So the solid, the three-dimensional object, it's going to be this yellow region flipped over. So the yellow region kind of looks like this, if I drew it. That's the shape. But it's going to revolve around this line up here. So it's going to flip over and have some symmetry, some opposite looking, if you think about it. So the symmetry, it'll flip it over. We're going to have a flat line going this direction. And in. And then probably something like this. So we're looking at a 3D object. Probably not my best solid, but it's good enough to get an idea. Something like that. So that's what we're finding the volume of. Here's our setup. Now we're ready to solve. And hopefully that helps you practice. These washer problems, the big R's and the little r's, are difficult.